What is ray tracing method and why we need to use ray tracing technique in the context of visible light communication? Wherein we model visible light rays, or we can say visible light propagation paths for the given area, like room with dimensions x equal to 6, y equal to 6 and z equal to 5. In the context of visible light communication and positioning, ray tracing is one common technique for channel modeling, especially when we want to model reflection from different objects and sources such as walls, furniture, ceilings, floor, intelligent reflecting surface, a new technique to optimize multipath reflections, or other surfaces. Before delving deep into ray tracing approach, let me brief you a closely related channel modeling, which is deterministic analytical geometry channel model. Fundamentally, deterministic analytical geometry and ray tracing are closely related approaches used in wireless communications to model how RF or VLC signals travel from a transmitter to a receiver. A deterministic and stochastic setups are adopted as they differ in their foundational math and execution in practical and simulation-based environments. Now, I will give you an example via research paper so you can better comprehend the difference between the two channel models. For example, papers, IRS-assisted VLP system. Theoretical lower bound and maximum likelihood estimator, and intelligent reflecting surface assisted visible light positioning follows deterministic analytical geometry for LOS path and IRS path, and in the communication theory sense we can say that papers equations inspired by ray tracing approach, because each reflected path is geometrically traced from each LED transmitter to the IRS small reflecting area and then reflected path/ray to the receiver. In short, we can say that these two papers follow first-order deterministic ray tracing approach. So, deterministic analytical geometry uses exact 2D or 3D coordinates, shapes, and positions of objects, e.g., walls, furniture, buildings, to define the environment and blockage models as mathematical equations. Employs explicit geometric relationships to determine things like visibility, antenna spacing, and angles of arrival. Primarily focuses on accurately mapping the physical boundary conditions, where obstacles begin and end, allowing engineers to calculate path loss directly using spatial dimensions and distances. So, what is ray tracing approach? Ray tracing model is a specific setup of channel modeling and analytical geometry that simulates individual electromagnetic waves propagation paths as individual distinct rays emitted by the LED transmitters. This approach uses optical principles like geometrical optics, GO, and the uniform theory of diffraction, UTD, to track how rays bounce, reflect, refract, or scatter off environmental surfaces. Focuses on predicting the multipath channel impulse response by calculating the exact delay, phase, and amplitude of all arriving rays at the receiver. So in short, ray tracing follows optical rays or propagation paths throughout the specific environment, and in the context of VLC, the tracing paths is given as LED to walls or furniture or other reflecting-refracting objects and then to the receiver. So, by understanding the deterministic geometry and ray tracing, we can adopt the approach either by deterministic or stochastic approaches, critically depend on the requirements and knowledge of the involved parameters. If I further discuss the stochastic ray tracing approach, it is based on probability or random distribution, where many rays are randomly launched from the LED according to its radiation pattern. Each ray is then followed as it reflects from the walls, ceiling, floor, IRS elements, and other objects in the indoor or outdoor environment. In the stochastic ray tracing model, Monte Carlo simulation is also commonly used to simulate the optical channel and analyze key performance metrics. Mathematically, LED-random direction-surface- new reflected direction-receiver. The received optical power or impulse response is estimated statistically by counting or weighting rays that reach the receiver. So, instead of calculating one known path analytically, Monte Carlo ray tracing estimates the channel from many random optical propagation ray paths. If I further simplify the meaning of stochastic Monte Carlo ray tracing, we can say that stochastic means probabilistic/random. Monte Carlo means a numerical method that uses many random samples to estimate a result. Ray tracing means following the path of rays as they travel, reflect, scatter, or reach the receiver.